In this session, we will understand the core features of C++ and how C++ program is structured. We will begin with a brief introduction to C++, followed by its features and advantages. Then we will explore the structure of a C++ program, compilation steps, keywords, and identifiers with examples. This session builds a strong foundation for object-oriented programming in C++. C++ is a powerful general-purpose programming language developed by Bijan Startup in 1979 at Bell Laboratories. It was designed an extension of the C language by adding object-oriented programming feature. C++ supports both low-level system programming and high-level application development. Interestingly, languages like Java and C# are conceptually derived from C++, making it a cornerstone language in computer science. This slide shows the features of C++. C++ is an object-oriented language, meaning it supports concepts such as classes, objects, inheritance, and polymorphism. It allows code reusability, which reduces development time. Although the source code is portable, the compiled program is platform dependent. C++ offers fast execution due to its compiled nature and provides a rich standard library that supports various programming tasks efficiently. These are the advantages of C++ programming language. C++ offers better management through pointers and a dynamic memory allocation. It delivers high performance, making it suitable for real-time system and game development. One unique advantage of C++ is that it supports both low-level programming, such as hardware interaction, and high-level programming, such as application development. This versatility makes C++ widely used in operating system, embedded system, and compilers. This is the structure of C++ program. A C++ program follows a well-defined structure. It typically consists of header files, namespace declarations, the main function, and executable statements. Header file provides necessary library functions. A namespace avoids naming conflicts, and the main function acts as the entry point of execution. Understanding this structure is essential before writing any C++ program. This is a simple C++ program that prints a message on the screen. The IOStream header file enables input and output operations. The using namespace std statement allows access to standard library access objects like cout. The main function consists of executable statements, and the return statement ends the program execution successfully. Header file in C++ contains declaration of functions and classes. The IOStream header file is commonly used for input and output operations such as cin and cout. Header files are included using the hash include directive, which is processed during the pre-processing state of compilation. A namespace is used to avoid name conflicts in large programs. The std namespace contains all standard C++ library components. By using namespace std, we can directly use objects like cout and cin without prefixing them with std : every time. The main function is the entry point of every C++ program. Execution always begins from main. It can return an integer value to the operating system, usually 0, which indicates successful execution. Without the main function, a C++ program cannot run. The compilation process in C++ involves multiple stages. First, the source code written with the .cpp extension is processed to the preprocessor, which handles directives like include and define. The compiler then checks syntax errors and generates object code. The linker combines object files and libraries, and finally the loader rolls the executable into memory for execution. The diagram illustrates the complete compilation process of a C++ program, showing how source code is transformed into an executable file. The process begins with the source code, which is the .cpp file written by the programmer. This file contains C++ statements, functions, and logic. Next, the code is processed to the preprocessor. The preprocessor handles directives such as hash include, hash define, and the conditional compilation statements. At this stage, header files are included, macros are expanded, and comments are removed. The output of the preprocessor is then sent to the compiler. The compiler checks the syntax of the program and converts the pre-processed code into object code, which is a machine level but not yet executable. After compilation, the linker comes into action. The linker combines the object code with the required library files, such as those containing definitions for cout and cin. It also removes external function references and produces a final executable file. Finally, the loader loads this executable program into main memory. Once loaded, control is transferred to the main function and the program begins execution. This step-by-step compilation pipeline ensures correctness, efficiency, and successful execution of a C++ program. So these are the various keywords and identifiers used in C++ program. Keywords are reserved words in C++ with predefined meaning such as int, float, double, char, bool, and void. Identifiers are user-defined names given to the variables, functions, and classes. Identifiers must follow naming rules and cannot use keywords as names. This is an example for data types. This example demonstrates basic data types like int, float, double, char, and bool. It also includes a void function which does not return any value. The program prints value of different types and calls the void function, showing how function and variable work together in C++. This code illustrates basic C++ data types. Integers stores whole numbers, float and double stores decimal values, char stores a single character, and a bool stores true or false. These fundamental data types are essential for storing and processing data in C++ program. This slides are example for auto static register extend keyword. The auto keyword allows the compiler to import the data type automatically. Register suggests storing variable in CPU register for faster access. Static variables retain their value between function calls. Extend is used to declare global variables defined in another file or later in the program. This code demonstrates a static variable. The static variable retains the value between function calls. Each time the function executes, the value of the count increases instead of reset. This behavior is useful for tracking state or usage count across multiple function calls. So this statement declares an external variable. The extend keyword tells the compiler that the variable is defined elsewhere in the program. It supports global data sharing across multiple files in large applications. Here, auto allows the compiler to automatically detect the variable type based on the assigned value. The register keyword suggests storing the variable in CPU register for faster access, although modern compiler handles this optimization automatically. This example for if, else, switch case default keywords. These are control statements allows decision making in programs. The if else statement checks conditions and executes code accordingly. The switch case statement selects execution path based on a variable's value. These constructs helps in implementing logical decision structure. This if else block demonstrates conditional execution. If the condition is true, the first statement executes. Otherwise, the else block runs. This structure allows program to make decision based on runtime values. Next, the switch case structure selects execution path based on variable values. Each case represents a possible match. The break statement prevents fall through. The default case executes when no condition match. This slide is a demonstration for while, do while statements. The loops are used to execute a block of code repeatedly. The for loop is suitable when the number of iteration is known. The while loop checks the condition before execution, while the do while loop executes at least once before checking the condition. This for loop executes a block of code a fixed number of times. Initialization, condition checking, and increment are defined in a single line, making it ideal when iteration count is known. The while loop checks the condition before executing the loop body. If the condition is false initially, the loop does not execute at all. It is useful when the number of iteration is not known beforehand. The do while loop guarantees at least one execution because the condition is checked after the loop body. This is useful when initial execution is mandatory. This slides in an example for break, continue, go to statements. The break statement exits a loop immediately, while continue skips the current iteration and moves to the next one. The go to statement transfers the control to the labeled statement. Although go to is available in C++, its usage is discouraged due to poor readability. The continue statement skips the current loop iteration and moves to the next one. The break statement immediately exits the loop. The statement provides fine-grained control over loop execution. This demonstrates the goto statement, which transfers control to a labeled statement. While supported in C++, goto is generally avoided due to reduced code readability and maintainability. This is an example of a return statement. The return statement sends a value back from a function to the calling function. In this example, the add function returns the sum of two integers. The main function then prints the returned value, demonstrating function invocation and the return flow. This function returns the sum of two integers. The return statement sends the computed value back to the calling function. Return statement enables data flow between functions and C++. This is an example of keywords class public, private, protected, virtual, this, new, delete. This example demonstrates object-oriented concepts. The class keyword defines a blueprint. Inheritance is shown using base and derived classes. The virtual function enables runtime polymorphism. Dynamic memory allocation is done using new and a delete is used to free memory. In detail, we'll discuss these concepts later with the example programs. Next, we'll move to the demonstration of const size of typed up keywords. The const keyword defines variables whose value cannot be changed. The size of operator returns memory size in bytes. Typedef allows creating aliases for existing data types, improving code readability and maintainability. With this, we conclude session 2 on features of C++ and program structure. You now have a clear understanding of C++ basics, program structure, compilation, keywords, and control statement. These concepts forms the foundation of object-oriented programming in our upcoming session. Thank you.